I've been making some progress on little bits and pieces. The first has been tidying up these track rod ends. These came secondhand from the UK. They go on the ends of this bar here, which is the track rod that goes across the front of the car from one swivel axle to the other. These are threaded, and it's actually a reverse thread on the opposite end so that they don't come undone, I guess, or so that you can adjust it easily just by turning the center. These are a kind of ball joint thing with a taper pin. So there's a housing with this sort of bush in it, and this ball drops through into there. You can see this one's quite rusty. If I can get it to go through. Here we go. So that's what gives you the motion that you need in the linkage. And this ball is sort of held down with this little cup that goes in the end, and then there's a spring which fits in there. It's going to be a bit tricky, and then there's a cap that goes over the top, and there's sort of space there for a grease nipple. These parts are available new through the spares, so I'm going to obviously have to replace this one because it's rusted through on the neck there, which is probably going to be some sort of stress point, and you want this all to be nice and clean. I'll probably get new springs for it, just because springs do tend to go weak over time, and these could be, for all I know, these could be the original springs, which would make them 90 odd years old. So these are going back together quite well. I've also fitted new bushes to the engine mounting brackets. So this there's a bronze bush that's pushed into there, so I bought new bushes, pushed out the old ones, and pushed in the new ones. They didn't have the length that I needed, so I had to get ones that were slightly longer, and then I just turned them down on the lathe to the right dimension. When I was doing that, I noticed on my original bracket that I had here that this was quite worn out. So I've ended up building this up with weld. I used the old bush and just pushed it into the hole a little bit to give me something to weld around that the weld wasn't going to stick to. So I was able to build that up with weld, and then I actually put this into the mill and milled those faces flat. And that's so that the shackle fits quite tightly up in there when the shackle pin goes through. There doesn't seem to be any sort of thrust washer on these. As far as I can tell, that's original. It just sort of pushes up against the sides of there, which will explain why this was quite worn out. It was probably about 1/8 of an inch, maybe 3/16 of an inch worn on here. This other one that I've got is in much better condition. There's no wear on it at all, really. So that's where the shackle pin goes through. So I'm making progress on those. This was powder coated originally, but I took all that off because I prefer a painted look. I've been using that sort of semi-gloss type paint, which comes up with a really nice hard enamel finish that's not too shiny. I just like the look of that. So these require painting. I want to give them a good etch prime first, and then I'll probably leave them in etch primer because I don't know what color the body's going to be. So if they're done in etch prime, I can at least bolt them onto the car, and then when it comes time to paint the car, the chassis is all going to be painted anyway, so they'll get painted then. The other job I've been doing is working on the lathe some more. The cam lock on the tailstock is working really well. I can't understate how much easier and nicer that makes doing everything on the lathe. It's just so much quicker. I also fixed up my keyless chuck here, which I wasn't using previously because it wasn't unlocking from the tailstock. So these are on a taper, and usually what happens is when you wind this all the way back, it pulls the taper onto a pin which sort of ejects this. Now this one is actually threaded. There's a hole in the end there for a threaded bar to go through, which is, I guess, for when you're mounting this in mills and things like that. The problem is the pin would go straight into that hole, so this wouldn't pop out, and then you'd have to sort of lever it out. So I just found a suitable bolt, and it seemed to be a UNC coarse thread. So I went through my junk box, found a suitable bolt, and just threaded that into the end and cut it off. So now the pin's got something to push against. So you can sort of lock that onto the taper, and then you can wind this back and it'll pop off as it's supposed to, like that. So I'll put that back, because otherwise the next time I go to use it I'll forget that it's not tight. So that's done, and I've been working on the little piece I need so that I can mount the change gears. That's what this little chart describes. It's quite hard to follow, but the way it's set up on this little lathe is you've got the different gears here, and they're sort of on T-slots. If I undo this, basically all this comes apart, and you can see there's a sort of T-nut there that runs in these slots, and that's how you put these gear clusters on and off. And it's actually quite clever. So you can loosen this off, and there's a little washer on the end here. This one here. And you loosen it off enough, and that will actually drop out. And you can see it's got a little lip in it, so that when everything's tight, that can't fall out. I'll sort of show why in a second. But by taking that out, you can pull the gears off to change the ratios without having to take this off all the time. And you can see that's kind of keyed. The gears have a little slot in them. And to get the full set of ratios on here, there's actually supposed to be 2 of these. And I was missing the second one. It didn't come with that, and it didn't come with the gears I needed. So you can sort of see there's a little sliding collar on there. This is all designed so that when this bolt is done up tight, this can still rotate, and those 2 gears are locked together because of this key, and the gears transmit the power through. So I've made up a new one of those, which is down here, and this was all just made up on the lathe and the mill from little scraps of metal I had. So it's not exactly the same as the other one, but it's close enough. The difference is this diameter of this shaft and this collar aren't the same as the original. Everything else is the same. So this is all kind of a match set now. But you can see how this collar goes onto there. And then there's a washer, which I can't really do with one hand. And then the little T-nut. This was really fun to make because I got to use the lathe. It's always cool when you're making parts for the lathe on the lathe, if that makes sense. And I got to use the mill, and it's all quite fine tolerances for this to work so that it all locks up tight, but the gears can still rotate. So that goes on there. And this shows why there's that little sort of shoulder on this little split washer, because that fits over the shaft, and then when all this is done up, it gets held by the little collar, so it can't drop out. And then when this is all done up tight, this outer assembly is all clamped, but that inner collar can still move. So like I say, this was all just little scraps of steel I had around. I just machined it up and cut the threads and things. This was, I'm not entirely certain if this is brass or bronze. I've actually just bought some brass rod, which is here. So this is 1/2-inch brass rod, and I'm going to use that to machine up the sleeve to repair the head here. Apparently that is the way you can do that. And this unfortunately was slightly small diameter. It wasn't quite big enough to make this. And then I remembered when I got this lathe, it came with some different bits of material, which is this stuff. So I machined it out of this, and I'm not entirely certain what that is. This here is also, well, this is obviously plastic, but I don't know exactly what sort of plastic. It's very slippery, so maybe it's nylon. But you can see I just cut a piece off one of these bars and machined it from that. When you do little jobs like this sort of hobby machining and stuff, you end up with you keep all the little scraps and all the little bits and pieces. So I've got a box of tiny offcuts, because often you are just making little fiddly bits and pieces like this. So for example, the ends of these bushes I trimmed off are now sitting in that junk box. But this now all should allow me to use these change gears that I printed. These have just been 3D printed. It should hopefully fit through there. And you can see how with that key you can set up pairs of gears that will spin together on this little thing. This is just PLA plastic. I'm not sure how well this will hold up, but I'm not exactly doing a ton of gear cutting, thread cutting rather. So I'm imagining it should be good enough. Obviously there are already plastic gears in this gear train. I'm imagining this is some sort of engineering plastic. I'm not sure exactly what. These are all plastic. So I'm going to give it a try and see if they work. The main reason I need to do this is because I need to make things up like the stud which holds the Riley gearbox in, and I need to be able to cut these threads on it. I can machine this up out of steel, no problem. It's cutting the threads that's a bit tricky, and these threads are a little bit too big to be able to do with a die set by itself. So my plan is to use the lathe to cut the thread. I can always clean up the thread with the dies and then be able to make parts like that. So I'll put all this back together. I have to figure out how deciphering this little chart and diagram is a bit fiddly. To work out the correct pictures and things that you need, but I've got the manual for this lathe as well, and that helps a little bit. One thing I would like to do with this lathe is the lathe itself has a 2-speed motor. So if we turn this on, that's the first speed, and then you can double the speed. The problem is stopping it. So here's the stop button, and it's kind of got, you press it down halfway and it stops the second speed, pops that up, and then all the way will stop it. But it's quite hard to do that. If you just press it all the way down and it's going at double speed, it just tries to turn off immediately, and it's quite harsh on the machine. So that's not too bad, but especially at the highest speeds, it's quite a jerk when you try to stop it like that. So I'm actually wondering if it's worth looking at getting a VFD for this machine, which is an electronic motor controller. The question is, would it be compatible with that motor? I'm not sure. But these lathes are pretty common. There's a forum for them. I'm sure somebody's already looked at this and figured it out. But some sort of VFD would give me much better speed control on the motor. And the other thing I'd really like is a bit more braking on it. So at the moment there's no braking. You can see it takes a little while to stop. So it would be good if it came to rest a bit quicker than that. But overall, I'm really pleased with this machine. I'm still getting the hang of it and figuring it out and still tweaking it to get the setup right. But it's working really well. I think it's going to be really handy for hopefully finishing off these car projects. And so just to prove this works, I've set it up with my new little mounting boss thing and a couple of the 3D printed gears. This is just set up in more or less the default position. But you can see and so I should be able to engage the half nut and the carriage should move. I've actually got it moving in reverse at the moment, but it is moving. Let's try it. Move forwards. So it definitely works. It's just a matter of how well it's going to hold up. Put that back to neutral.